we're going to be working with algebra, solving linear equations, and using manipulatives to do it with. Manipulatives are concrete objectives used to help students visualize math problems. They're objects that you can move around and you can really show what you're thinking. Algeblocks are what we're going to use today, and they look like this. They're 3D manipulatives that are used with a quadrant mat, which looks like this. They aren't specific dimensions, so they can be used for a variety of different problems. For example, when we used our base 10 blocks, they were specifically 1, 10, hundredths, thousands, and they went up by a specific increment. In the Algeblock case, you don't have that. They're smooth-sided and they're not broken up into any specific dimension, so they can be used for a variety of different problems. They come in larger cubes, smaller squares, but for today, we're just going to be using these rectangles and these units. The quadrant mat has a positive and negative side set equal to another, and a positive and negative side on the other. Algeblocks are going to be the physical representation of our algebraic numbers. The yellow rectangles represent x, which is the unknown value that we're going to be solving for, and these green cubes are going to represent 1. So let's try and do some problems. Let's start out with an easy one. Our first one is x plus 5 equals 10. So how we set this up is we take 1x, which is going to be our yellow unknown, on one side of the equal sign, and on the other side of the sequence map, we're going to put, well, we have to put our plus 5 here, and then we're going to put our 10 over here. Now, what you do first is you have to try to get both sides equal by solving for your unknown. So what you first do is these are like terms because they're the same thing. And so what we're going to do is we're going to cancel them out. We're going to match them up. And we're just going to take them away. And this is a fair thing to do because when they're the same thing on both sides, they will cancel each other out in instances like this. So what we have left is we have our unknown value, which is x, is equal to 5. And in this case, you can't do anything else because you do not have anything else to cancel with anything else. And so your unknown is 5. Let's try a harder one. 3x minus 1x equals negative 1x plus 9. Now in this case, you're going to set it up a little differently. Last time we only dealt with positive values. Well, in this case, we have some negative values, which will go in the negative quadrant of our sentence mat. So let's set this up. 3x does not mean that you have 3 units and 1x. 3x means that you have 3 x's. So that goes in our first quadrant. And then we have a negative 1x, which goes down in our negative quadrant. And these are equal to a negative x, another negative x, plus 9. So that's positive, and it's going to go in our upper quadrant. I'll turn it around so you can see how we have this set up. Now, what we first need to do is we need to start canceling some things out. Now first, the most obvious thing to do is to take this negative on the left side and this negative on the right side, pair them up, and take them away. As we said before, this is legal because when you move something over to the equal sign, it cancels them out. So, this is going to leave this mess right here. So you're wondering what you're going to do with it. You have 3 x's and you have 9 green cubes. So what you want to do is you want to think of ways that you can make these green cubes evenly split up into sets of 3. So we can play with these, and we're going to find that you can make 3 equal sets of 3. So what you can do is you can pair these up, and what you see here is that one of our unknowns is equal to 3 units, therefore making our unknown 3. Does that make sense? Good. Now we're going to move on to something a little bit harder still. It's 4x plus 3 equals 3x plus 8. In this problem, all we have is positive, so we don't even have to worry about the negative quadrant. So let's lay this out. 4x, so as we said before, you have 4 unknowns, not 4 cubes and 1 unknown, but 4 unknowns, plus 3 is equal to 3x, another 3 unknowns, plus 8. And there's that. I'll show you what we have here. So what we're going to start doing is we're just going to start matching up our cubes and canceling them out. When you move one of these across the equal sign, it does cancel it out. So we can do that 3 times, which leaves us with 1x plus 3 is equal to 8. Now, what else can we do? That's right, we can take our x's and we can cancel out the ones that we do have left. Now, in this instance, we can't match any other greens with any other yellows. And we can't match anything up. We can't match yellows with greens and move them off because they're not the same. They have to be exclusively different. You have an unknown and you have knowns, and you can't mix those. So our answer here is x, which is the yellow block, which is represented as the unknown, is equal to 5. All right, we have one more, and it's a little tricky. This time we're using parentheses. Now in parentheses, it's a whole group. So in this case, we have 2 parentheses, 5 minus 2x parentheses is equal to 18 minus 3x. Now, at first, you might be thinking that you want to take 2 green cubes plus 5 more green cubes and 2x, like that. Well, that's not right. What's in the parentheses is a group, and the number in front of the parentheses is telling us how many groups of that we have. So in our case, we're going to have 2 groups of 5 minus 2x. So let's see. You have minus 2x and 5. And then you have another group of minus 2x and another 5, which is positive. The negative x, 2x is negative, but it's positive 5. And so that's how we set this guy up, like that. You have 2 groups of that. And this is equal to 18 minus 3x. So you have a negative 3x, which goes down in the bottom. And then you have a positive 18. Give me a second to count this out. Alright, squeeze them all in here. So you're looking at this and you're going, oh wow, I have a lot of negative x's and a lot of positive green blocks. So what we're going to start doing is we're just going to start simplifying as we had before. Once we have it laid out, it's pretty easy to finish pairing it up. The hard part is understanding that what's in the parentheses is a group that's just going to be replicated by the number in front of it. So let's work this out. We can pair, pair, cancel, pair, and then we can do that with our huge groups of our green tiles. And remember, we can do this because as long as we're taking one from each side, it's legal. When you can add or subtract from either side as long as you're doing it to each side of the equal sign to keep the balance equal. Okay, now in this case, we have a negative x and a positive 8. And this is not our final answer. So what we're going to do is we're going to take, and like I said, you can add and subtract as many as you want. What we're going to do is we're going to add a positive x up there. But what we do here is right down here. But you can't just add this. You have to make the group whole. So what we're going to do is we're going to take 8 green blocks and add it to the bottom down here. Now you're wondering what I can do now. Essentially, what I just did is I added to both sides to make it equal. Except I did that. No, I did that right. And so what we can do now is we can take this whole negative side away. Because what we did here, except I did that wrong, I got it all mixed up. Let's go back. And you might make these mistakes too by putting them in the wrong quadrants. So what we should have done here is we should have added the positive up here and the negatives down here. Do you see why that's happening? Because we added it to one side, so we had to do the same thing to the other. So in this case now, we can essentially cancel these out and scoot these to the side. So our answer now is x is a negative 8 instead of a negative x is 8. Because you can't really have a negative unknown value. It needs to work out like this and keep the balance. Alright, so now I hope that you can take what we learned during the video using the Algeblocks and the sequent mat and take these and work on some more problems.